So the sheet of paper I passed out to you looks like this. On one page, or on the top you have this, and on the bottom you have that. It sets up what is called the law of sines, which is a relationship between the sides of a triangle versus the sines of its opposite angles. So what we're looking at here, and typically, as far as trigonometry is concerned, typically when they name a triangle ABC, little a is opposite side A, little b is opposite side B, and little c is opposite side C. That's usually how they set these pictures up. A, B, or C could be acute, obtuse, or right. Okay, but this particular property, the law of sines, is used specifically for triangles that are not right triangles. Okay, if I have a right triangle, I'm going to use SOHCAHTOA like I normally would. But if I have any other triangle that doesn't have right angles in it, I'm going to have to use the law of sines or the law of cosines in order to find missing pieces. With that in mind, this is the law of sines. Once you're ready to use it, you just plug your numbers in and work it out. All right? The two scenarios that we're going to be working with here are case 1, case 2, and there's actually 3 specific situations that allow you to use law of sines. These two are pretty much the same. If you know angle, side, angle, or angle, angle, side, here's why they're the same. Angle, side, angle means I know an angle, and I know a second angle, and I know the side between them. Okay. If I know 2 angles, how many angles can I find? I'm in a triangle and I know 2. I can find all 3, right? Very easily. So if I have angle, side, angle, or if I have angle, angle, side, either one of those, I can very easily find the third angle. So regardless of which one it is, it's the same scenario. Step 1, find the third angle. So now you have angle, 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 side, no matter what they gave you. And then use the law of sines to find the other 2 sides. Everything we do today is going to be this case. Case 1. Tomorrow we're going to investigate case 2. Case 2 is a little more complicated. You can see there's 6 steps instead of 2. And actually there's 8 steps because you do steps 5 and 6, and then you repeat, or sorry, 4 and 5, and you repeat steps 4 and 5 again. So yeah, it's a little more complicated. It's not hard to do. It's just got more steps. So with that in mind, this is what we're going to look at today, and the way I do it on the board today is how I want you to do it on your paper. So what you see go up on the board, that's what your work should look like on your paper every time. So with that in mind, let's do this. I'm going to have a calculator up at all times for calculation purposes. There's quite a bit of calculation going on in these problems. So, first step. It says for triangle XYZ, what is measure angle Y? Then find XZ and YZ to the nearest tenth. And they're giving us rounding directions, so we'll round to the directions they tell us. If they don't give us rounding directions, I would like everything rounded to 2 decimal places that gets rounded at all. All right? So first step is diagnosis. What type of problem is this? Can I use SOHCAHTOA or not? If I can use SOHCAHTOA, it's better to do that. So if I got a right triangle, I'm going to use that. All right? You can see here that this angle is 51 degrees. This angle is 77 degrees. And then we have this side 7. So we're looking at seeing what they're telling me for information. So looking at this picture, can everybody see I've got angle, angle, side? All right, so I want you to write that down on your paper, what you have. Because again, what you're going to use is based specifically on what you have given. So you need to identify that, okay? And I want to make sure you do identify that you're making your decisions based on a reason, not just haven't used this step recently, so I'm just going to do this, right? So I recognize it as an angle, angle, side setup. And this is law of sines, case 1. Okay. So I want you to tell me what it is that you're given and what you're going to use to fix it. Okay, just so you know, there's a law of cosines, case 1, and law of cosines, case 2 as well. So make sure, even though everything right now is going to be law of sines, obviously, because you haven't learned law of cosines yet, still, I see angle, angle, side. I know that means law of cosines, and it's case 1 because it's angle, angle, side. Then I'm going to follow the directions on the sheet of paper that says step 1, find the third angle. How much do these add up to? These 2 right here?
128.
128 for those 2, right? So, measure of angle Y is going to equal 180 degrees minus 128 degrees. 180 degrees minus the two angles they gave me. So that's 52 degrees. Okay, notice this is almost an isosceles triangle. We missed it by 1 degree. If those two angles were the same, then those two sides we don't know would be the same, right? But since they're different, the two sides we don't know are different, but they should be pretty close to each other. It's kind of a self-checking type thing. Not isosceles, but pretty close. All right. The other thing I like to do, instead of using x, z, y, z, x, y as my unknowns, I like to use x, y, or z. So big Y is opposite little y, big X is opposite little x. I'm going to call those two sides x and y. If you draw the picture of the triangle on your paper, which you should, and you name things what they are, if you get x equals y equals, and I can see what x and y represent, that's fine. You don't have to say x, z equals, y, z equals. I'll be fine with x and y equal. So, once I get the third angle in the triangle, every triangle is going to look the same. I'm going to have three angles on one side. I'm going to create this proportion. So the steps for the law of sines looks like this. Fraction bar 1 equals fraction bar 2 equals fraction bar 3. On top, I put all the side measures. My advice, put the side measure you know in the middle. Put the side measures you don't know on either side of that. You don't have to put 7 in the middle, but it makes it easier to do all your work if you put the 7 in the middle. X on the left, Y on the right, that doesn't really matter. It doesn't matter where they are as far as what makes it easier, but having 7 in the middle just makes life easier. On the bottom, I'm doing sine of angles, and the angle opposite side x is 51 degrees. The angle opposite 7 is 77 degrees. And the angle opposite y is 52 degrees. Now notice I didn't write 51 degrees, 77 degrees, 52 degrees. I wrote sine of 51 degrees, sine of 77 degrees, and sine of 52 degrees. It is the law of sines. We must take the sine of each of these angles. I don't know what the sine of 51 or 77 or 52 is, so my calculator has that information, so I'm going to ask it. So sine 51 equals, I'm going to go 4 decimal places, so it's going to be 0.7771. I'm going to type in sine 77 equals, and it equals 0.9744. And sine 52 equals, and it's going to be 0.7880. There's absolutely no reason any of you should know any of those numbers without a calculator. So use a calculator to evaluate the signs of those numbers and then write them in. Now you've got a numerical proportion, and the reason I want the 7 in the middle, the one I know in the middle, the left two fractions cross multiply to get me x. The right two fractions cross multiply to find me y. So if I cross multiply this, I'm going to get 0.9744 times x equals 0.7771 times 7, which is 5.4397. You're typically going to get that kind of look on these problems. You're going to get some number times x equals some number. We're rounding everything to 4 decimal places, so we tend to get these large decimal expressions, whatever they are. I'm going to divide by 0.9744 because that's what's in front of x. I want to get x equals, right? So I'm going to divide 5.4397 divided by 0.9744 equals. It does say round to the nearest tenth. So at this point, that's my final answer for x. I'm going to take that answer to the nearest tenth, so I'm going to write 5.6. If I repeat the process for y, I'm going to cross multiply the two ones boxed off in purple. So 0.9744 times y is equal to 0.7880 times 7. That comes out to 5.516. Again, something times unknown equals something, so I'm going to divide both sides by the 0.9744. 5.516 divided by 0.9744 comes out to 5.66, so 5.7 if we round to the nearest tenth. And I'm doing my final rounding to the nearest tenth in the very last step. I'm going to keep it to 4 decimal places all the way through to that point. All right? So 5.6, 5.7, and 52 degrees are all the missing pieces in this picture. And any angle side angle or angle angle side scenario is going to work the same way. Find the missing angle first, then it's 3 angles on the side, set your proportion up, calculator evaluates your sine values, and then you cross multiply. Again, using the calculator to calculate a bunch of stuff. I write down stuff on my paper as I find it. Don't try and punch it on your calculator to hit equals. I want you to go through the process. As you calculate a product, write the product down. As you calculate a quotient, write the quotient down. And round your final step.